In 1976, the World Manufacturers' Championship essentially became a one-car show. The Porsche 935 entered the field and immediately began a years-long run of absolute dominance across national and international racing series. The governing body of motorsport, the FIA, had just introduced the Group 5 category. The rules were written to force teams to use production-based cars, strictly limiting how much they could alter the original chassis. But where the regulators saw boundaries, Porsche race engineer Norbert Singer saw a creative invitation. Getting the 935 approved to race required a brutal homologation process. Singer and his team had to stand in front of skeptical FIA inspectors and defend every widened fender, every repositioned mirror, and every aerodynamic panel, proving they still technically complied with the road car regulations. Once the car passed inspection, the burden shifted to the cockpit. In an era before two-way radio contact, the driver was entirely isolated. Adapting to the car's extreme mechanics required total intuition and split-second communication via pit boards held up on the main straight. Porsche secured their victories in the garage first. They read the rulebook, found the gray areas, and engineered a permanent mechanical advantage before the green flag ever dropped. The 1976 homologated model had one glaring physical limitation. Its massive single turbocharger generated immense top-end speed on the streets, but the time it took for that large turbine to spin up created severe turbo lag. Drivers had to wait for the power to arrive. This diagram maps Porsche's 1977 solution. Instead of routing all the exhaust gas into one massive chamber, they split the airflow. Two smaller turbochargers require far less pressure to spin up, practically eliminating the lag. With power arriving instantly upon throttle application, the 935 became a precision instrument. Drivers could navigate tight corners and immediately apply predictable, controllable thrust on the exit. The engineering team then turned their attention to the 2-liter sprint class. To qualify, they had to shrink the engine to 1.4 liters, but more pressingly, the chassis had to meet a brutally low minimum weight requirement. They created the 935 Baby through a ruthless process of subtraction. They stripped out the steel underbody and welded in an aluminum frame. They removed the seat adjustment tracks. They evaluated every single gram of metal on the vehicle. The obsession with weight reduction went so far that engineers actually took a drill and punched holes through the metal of the driver's ignition key. The Baby weighed in below the FAI's minimum limit. By ruthlessly removing everything that didn't contribute directly to forward momentum, Porsche dominated the sprint class. By the autumn of 1977, Singer realized the Group 5 rules allowed for extensive modifications to the bodywork. He stopped trying to optimize the familiar Porsche 911 silhouette and decided to completely redesign the car's aerodynamic profile for the grueling 24 hours of Le Mans. The result was the 935-78. The paddock immediately nicknamed it Moby Dick. It featured a radical long tail design and smoothed-over wheel covers, abandoning the traditional upright shape of a street car in favor of pure, uninterrupted airflow. This cross-section illustrates the technical leap required to power it. For the first time, Porsche mounted water-cooled 4-valve cylinder heads onto their traditional air-cooled engine block. This hybrid cooling system allowed the 3.2-liter flat six to safely generate up to 845 horsepower. Because the engine could survive that intense thermal load, the driver could hold the throttle wide open. Down the massive Hoonadier Straight at Le Mans, the Moby Dick hit an astonishing 366 kilometers per hour. Singer considers this car the crowning achievement of the entire program. It was a machine built at the absolute edge of the regulations, pushing the 935 out of the realm of standard racing and into the territory of experimental physics. The final vehicle in this lineage barely saw a starting line. The original 1977 test car ran exactly one race at the Nürburgring. Its actual job was to serve as a rolling think tank. It was a disposable testbed where engineers could bolt on highly volatile prototypes, collect the telemetry, and eventually filter those successful components down into their customer racing programs and road cars. It even functioned as a high-speed wind block. Track cyclist Jean-Claude Rude used the aerodynamic wake of the 935 test car to attempt a world speed record on a bicycle, aiming to pedal past 240 kilometers per hour in the vehicle slipstream. When Le Mans winner Timo Bernhard and Norbert Singer review the archives today, they focus on the specific environment of the Porsche garage in the late 1970s. The team operated under extreme time pressure, constantly re-evaluating their own physics to solve problems the regulators hadn't anticipated yet. The win record of the 935 secures its place in motorsport history, but the engineering process behind it proved that the most valuable innovations happen exactly where the rulebook tells you to stop.